Hi, I'm Scott Gerben, Crane Application Engineer for Siemens Industry USA. This is the fourth in a series of videos introducing SIMOCRANE Basic Technology V5.0 for the SINAMICS S120 drives platform. This video will cover position control functions that include the target generator, target controller, and actual position velocity blocks. Unlike some of the previous videos in this series, these three blocks all work together to provide positioning control in the drive. So, while they are all standalone blocks that perform specific functions, they must be combined to achieve positioning control in the drive in SIMOCRANE Basic Technology V5.0. We will cover the blocks individually in the order they pop up within the script. However, it is important to remember that these three blocks go together when utilizing position control. When the script execution begins, you need to first parameterize the main drive block. You can activate inching mode when using the target generator block, which we will describe later on. However, the input that controls inching mode is directly controlled from the main drive block. This means that you will actually parameterize the inching mode input of the main drive block to enable inching mode. You can use a PZD bit or digital input feedback during script setup of the main drive block to enable inching mode. Also be sure to parameterize the positioning mode input within the main drive block at the beginning of the script execution. Only one drive mode should be active at a time, so it is important to use separate digital input or PZD bits to parameterize these inputs. Positioning mode will effectively enable the target generator and target control blocks, allowing them to slow down and stop the drive at the calculated target positions that we will specify in the target generator block. The next block to parameterize in the script will be the actual position velocity or APV block. Although we have described this block briefly before and how to disable it during script setup, we will now properly show how to set up the block so that positioning mode can be effectively carried out in this project. Taking a look at the APV block diagram, you can see the main block inputs and outputs. This block converts the drive speed to velocity and calculates the actual position of the axis in millimeters. The position can be referenced at standstill or during travel. During script setup of the APV block, start by parameterizing the Boolean input that enables the APV block at enable act pause vel. You can use a PZD bit digital input feedback or simply enable the actual position velocity block by selecting one from the drop-down menu. The rated speed in and maximum speed in inputs will be set to the motor rated nameplate RPM speed from the drive and from the reference speed of the drive, respectively. Although it is suggested to keep these default values selected, they may be adjusted as desired. Next, you should calculate the value for maximum velocity in and insert this value in millimeters per second for this block input. The application note available from the SIMOCRANE Basic Technology V5.0 operating instructions describes how to accurately calculate this value. For convenience, the formula for calculating this value is shown here. You might have to adjust this value after initial commissioning to get the most precise drive operation possible. However, the initially calculated value should be very close to the actual maximum velocity of the drive in millimeters per second. The last inputs to set up on the APV block are the homing related bits. The start homing input should be set to 1 when you would like to home the position of a crane axis. Doing this will effectively reset the actual position output of the APV block. Next, you can actually define what the homing position should be in millimeters when homing the axis. Although most applications will use the default 0 millimeters for the homing position, you can change this as desired. Finally, the latency time can be set in milliseconds. The latency time effectively compensates for the runtime delay when homing is performed during travel so that the latency pos offset output of the APV block can add a slight offset to the homing position internally. This ensures that when homing occurs during crane travel, the time it takes for homing to reset the position is accounted for when recalculating the actual position after homing. Next, taking a look at the target generator block diagram, you can see the main block inputs and outputs. The target generator block is used to generate a target position and target velocity input for use with the target control block based on user inputs as well as position feedback from the actual position velocity block. During script setup of the target generator block, you can parameterize an exact target distance in millimeters and the target dir pos and target dir neg inputs. You can also specify an inching distance in millimeters if inching mode will be utilized. From the target control block diagram, you can see the main block inputs and outputs. The target control block makes it possible to accurately position the drive at a specified target by allowing for target control or path control. During script setup of the target control block, you can parameterize the positioning accuracy of the target control block. The KP constant and overshoot correction inputs can also be parameterized. However, it is generally advised to leave these inputs at default values until after initial commissioning of the drive. The other two inputs you will be asked to set up are the enable creeping and creeping speed inputs. Creeping mode is covered in detail in the SIMOCRANE Basic Technology V5.0 operating instructions. To briefly describe this mode, it allows the calculated target to be overshot on purpose during the approach to the target position at the speed parameterized in creeping speed. If the creeping mode will not be utilized, you should set enable creeping to 0. Otherwise, you can parameterize a digital input or PZD bit to control this mode. Finally, you will be prompted to set up the ramp function generator or RFG block. Since setup of this block is covered in video 2 of this series, it won't be covered here. However, it is recommended that this block is set up correctly, as it is crucial to the operation of the drive running smoothly and properly ramping up and down the motor regardless of which crane functionality is being applied. Once the script setup has been successfully completed, you'll see a summary screen of your selections. Additionally, the positioning mode, inching mode, and creeping functions can be used in the drive. Now you're ready to utilize the positioning function blocks included in SIMOCRANE BT V5.0. If you'd like more information on SIMOCRANE BT V5.0, a good place to start is usa.siemens.com/cranes. In our next and final segment in this series, we will look in deeper detail at the master-slave hoist setup using the BT V5.0 software. Please use the link in the description below to find this video.